All right, we're going to be looking at how to solve systems of equations, and instead of graphing them, this time we're going to look at a process called elimination. The idea of elimination is to temporarily get rid of one variable so that we can solve for the remaining variable and then go back and use that answer to help us find the second number. Again, we're looking for an ordered pair that is the solution to these two equations. So in other words, if I were to graph them, it's the point where they would meet. That's what we're looking for, but instead of graphing, we're going to use a different process. So where it says rule, it says to eliminate a variable, the numbers must be the same and the signs must be different. So when I'm looking here at this first one underneath the word rule, I see that I'm looking for opposite signs. So if you look at the y values, you've got 6y positive and 3y negative. Now the numbers aren't the same, but our signs are already different from each other. So what I would need to do is do something to that 3 to make it the same number as 6. So in this case, what I would do is I would multiply everything inside of that parentheses, that whole entire problem, by 2. It doesn't change the value of the problem. It doesn't change the value of anything, but it makes it work for what we need to do. By multiplying by 2, this would become 4x minus 6y equals a negative 30. So then, if you look, my y's would eliminate each other. 6y minus 6y would be 0. And then I could go and solve for x. Again, the same thing on the other side. If I look at the second one, I've got 5x and negative 3x. I've got negative 2 and positive 7. So in this case, they both have opposites, and so I could make the choice of what to do. So then I want to look at the numbers with 5 and 3. I know their common number would be 15. So I would need to multiply 5 by 3, and I would need to multiply negative 3 by 5 in order for them both to be 15. And that's the process of elimination. So we're going to take a look at 3 different examples to see how that works. Okay, if our numbers are not the same and our signs aren't different, we're going to have to do something with multiplication to make that happen. So let's look at this first one. It says 6x minus 8y equals negative 6. And then we have 4x minus 10y equals 10. Now, neither one of those problems have an opposite, and neither problem have the same numbers with x or with y. So what we need to do is we're going to have to change both equations. So I'm going to pick x. Okay, x is going to be a little bit easier with the numbers 4 and 6. I'm looking for the least common multiple. Okay, I'm looking for the LCM of 4 and 6. And I know that 4 and 6 have the number 12 in common. The first multiple that they both have is 12. So I'm going to ask myself, what do I need to do to 6 to turn it into 12? Well, that means I need to multiply it by 2. And then I need to ask myself, what would I do to 4 to make 12? And the answer would be to multiply by 3. Now the problem is that that would still make both of them positive. So I need to make the 3 a negative 3. And so I'm going to distribute first a 2 in the first equation and then a negative 3 into the second equation. So 2 times 6x makes 12x. 2 times negative 8 is negative 16y. And then 2 times negative 6 is negative 12. All right, then I'm going to do the same thing with 3. Negative 3 times 4x is a negative 12x. Negative 3 times negative 10y is a positive 30y. And then negative 3 times 10 is a negative 30. All right, now, my next step is to combine those like terms. So I'm going to go 12x minus 12x is a 0 pair. Negative 16y plus 30y makes 14y. And then negative 12 and negative 30 make negative 42. And again, my goal is to solve for y. Now that I've eliminated x, I'm going to find the y value that works. I'm going to divide both sides by 14. So a negative 42 divided by 14 means that y equals a negative 3. So now I automatically have half of my answer. I know that the ordered pair of my answer is going to be something and negative 3. But how do I find out what that other value is? What I do is I go back and I take the first equation and I'm going to write it, but I'm going to replace the y with a negative 3. So I would say 6x minus 8, but instead of y, I'm going to put negative 3, equals a negative 6. And then I'm going to do the math. If I've got my calculator, I can use InSolve. If I don't, I've got to do it by hand. So 6x, and then a negative 8 times a negative 3 is plus 24 equals a negative 6. I'm going to subtract 24 from both sides. So I have a zero pair here. So 6x equals negative 6 and negative 24 make negative 30. I'm going to divide both sides by 6 to find the answer for x. So x equals a negative 5. Negative 30 divided by 6 is negative 5. So my answer or my solution would be negative 5, comma, negative 3. And that's the spot where I'd graph both of those equations. That's where they would cross or touch. All right, now we're going to look at the second one. We've got x plus 3y equals 5 and 2x plus 6y equals 2. All right, now, I don't have opposite signs and I don't have the same number. So I'm going to look again at x. I've got 1x and I have 2x. So I'm looking for the least common multiple. Well, the least common multiple of 1 and 2 is 2. So I don't have to change the bottom equation because it's already a 2. But what I need to do is I need to change the top equation by multiplying by 2. Because 2 times 1 is going to give me 2. But it still won't give me the opposite that I'm looking for. So I'm going to change that to a negative 2. Again, I want one of my x's to be positive and one to be negative. So a negative 2 times 1 is a negative 2x. A negative 2 times 3y is a negative 6y. A negative 2 times 5 equals a negative 10. Again, I don't have to change the second equation because it's the number I already needed. So 2x plus 6y equals 2. All right, now again, we're going to combine like terms all the way across. So negative 2x plus 2x is a zero pair. Negative 6y plus 6y is also a zero pair, which means I'm left with nothing on the left. On the right, I have negative 10 plus 2 is negative 8. Now, does 0 equal negative 8? The answer is no. This is a false equation. Because this is false, we know that we have no solution. Since 0 does not equal negative 8, we have no solution. All right, now let's take a look at our very last one. We have 6x plus 10y equals 0 and negative 3x minus 5y equals 0. Now, something different that we haven't had before is that we have equations with opposites. We've got a positive 6x on top, a negative 3x on the bottom, but our numbers aren't the same. So again, we're looking for the LCM of 3 and 6. Well, I know that 3 times 2 is 6, so my least common multiple is 6. So I'm going to multiply the bottom equation by 2. So I'm going to rewrite my first equation, 6x plus 10y equals 0. And now I'm going to multiply 2 to negative 3x, which is negative 6x, 2 times negative 5y, which is negative 10y, and then 2 times 0, which is still 0. Again, I'm going to combine like terms. So negative 6x minus 6x is 0. 10y minus 10y is also 0. So on the left side we have 0, and then 0 plus 0 is 0. Does 0 equal 0? Of course it does. That is a true statement. And so therefore we have what we call infinite solutions. So we went from an equation at the top, systems at the top where we had a solution of -5 comma -3. We had systems in the middle that had no solution because the answer that we got was not true. And then at the bottom, we have a situation where our two systems had an answer that was true, and therefore we have infinitely many solutions. Again, let us know if you have any questions. Thanks.